Sorry. Don't do this to me. Yes.
For those of you who don't know me, my name is Mrs. Nichols. I'm just one of the other geometry teachers at the school that you were going to be visited by. You'll be visited by one more, and then you'll have seen all of us. Okay, and then we're going to kind of cycle through again for the rest of the boot camp. So I'm here until 11:55, and then I'm going to switch out, and Miss O'Connor is going to come in. She's going to talk to you about Unit 4. So for Transformations Unit 2, you should all have the worksheet now. It says Unit 2 Transformations EOC Review. We're going to go over the basics, some basic key terms I thought were important for Unit 2, and then we're going to go into some example problems, okay? I haven't really been able to get through all 7 in a class period, but at the end of the period, I'll make sure you at least have all the answers, and that way you can ask your teacher once the boot camp is over. So I am going to spend a little bit of time on these equations here because you do have to know how to graph equations of a line to reflect over. But we're going to start with the basics. The first transformation is a translation. A translation is when a figure slides the same distance and in the same direction. So in the time I've just been talking, I have moved my location from over there to over here. I did not change my orientation, meaning I'm still upright. I'm not laying on the floor. I'm not standing on my head. My orientation is the same. I'm still the same size and shape as I was when I was standing over there. So the orientation, size, and shape did not change when I translated myself, okay? So because the size and shape did not change, we say that that has rigid motion. Okay, rigid motion is when the original figure and the new figure are both the same size and shape, and there's another word for that. What does it mean when two figures have the same size and shape? Starts with the letter C. Congruent. Okay, so if a figure has rigid motion, that basically means it's congruent. The original and the new are congruent. There's a general rule for translations that I'm going to give you, and it is that you take the x and y value and you add some integer a and b. So a and b are just integers, meaning they're whole numbers or they're opposites. So it could be something like x plus 2, y minus 4. That could be an example of a translation rule. Now, I'm going to go over a bunch of rules with you guys, and I'm not suggesting that you memorize every one of these rules. I feel like that's not necessary. There's too many. Some of them are too close, and it would be, even if you did memorize them, it would be too easy to mix some of them up. So what I'm asking you to do is pay attention to what they look like. The translation rule is very unique from the other rules. This is the only rule that includes the addition and subtraction. So you have your x and y, something is being added and something is being subtracted. Okay, that translation rule is unique to that type of rule. All of these rules we're going to see here for a reflection, you're going to notice they're all very similar. Okay, so a reflection, this is what you see when you look in the mirror, if you were to take a selfie. Okay, a reflection, excuse me, is when a figure flips over a given line and it does not change the size and shape, which means it also has rigid motion. Okay, so there's different types of reflections. There's actually 5 listed on the board. The first one is a reflection over the x-axis. The x-axis reflection, x-axis is your horizontal. Literally, if you're up here, you reflect over, you're down here. If you were down here, you reflect over, now you're up here. Okay, so x-axis reflection has a rule. The rule is x comma negative y. Now, there's a misconception with the rules that the x is not negative, but the y is, so the x will always be positive and the y will always be negative. That is not what that rule means. The rule means that whatever your x value was before, it will stay. So if I have point A at -2, -4, and I reflect over the x-axis, so I apply this rule, x, I'll get right here, x comma negative y. That does not mean make the x positive and keep the y negative. That's not what the rule means. The rule means keep the x exactly the way it is. Okay? So what would my new x value be? That should not be prime. It would still be -2. And what would my new y value be if I make it the opposite?
4.
+4. Okay, so keep in mind, anytime you see a negative in a rule, that does not mean that that number has to be negative. It just means whatever it was in the original point is now the opposite. Okay? So the rule for a y-axis reflection, this is just reflecting over this vertical y-axis. So if it was here, it moves here. If it was here, it moves here. Okay? So the y-axis rule is -xy. So this time the y stays the same, but the x becomes the opposite. So this is just reflecting over one of these, and all you do is count vertically or horizontally to get to that point. So if you're reflecting this over the x-axis, you're literally counting 1, 2, 3. Got to the x-axis, count 1, 2, 3. There's your new point. Okay, and if you're reflecting over the y, you're just counting the other way. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'll call that double prime because it's a different transformation. Okay, so this is a basic x and y axis reflection. Then we move on to these lines. We have the line y equals x, y equals -x. They typically don't give you these lines on the graph. The x and y axis, they're already on the graph because they're the axes of the graph, right? But the lines, these lines are going to be diagonal and they're not going to typically give them to you. So we would have to create that line. So I'm bringing up something that you have on your reference sheet because you're going to have that reference sheet for testing. On the reference sheet, which is like this much stuff, they actually have this equation. This is the equation of a line, y equals mx plus b. It also says on the reference sheet that b is the y-intercept and that m is the slope. So they give you that information. So if I was trying to graph the line y equals x, okay, I need to know what the y-intercept and the slope is so that I'm able to graph it. So the b, the plus b, is what the y-intercept is, but what's being added here? Do you see anything being added? No, nothing? What number typically is used to represent nothing? Huh? So let me ask this. If you had nothing in your bank account, what number would it be? Okay, so nothing is 0. So since nothing is being added, we can now conclude that 0 is being added because that doesn't change it. So that means my first point is the y-intercept of 0 on the y-axis. Okay, then we need the slope, the m. Again, there's not anything there, but this is different because this is not being added or subtracted. This number is being multiplied times the x, so it can't be 0. So what is understood to be here in front of the x? A 1. Okay, so I now know that my slope is 1, and I can use that slope to graph more points by doing that rise over run. But I need to make it a fraction. What is 1 as a fraction? 1 over 1. So remember, you can make any number a fraction by putting it over 1. Okay, so that means I'm going to rise 1, run right 1. So from this point, go up 1, right 1, up 1, right 1, up 1, right 1, and so on until you've created this line. And you can go backwards too to continue your straight line. Now I have the ability to reflect a point over that diagonal line, but I have to count it a little bit differently. So if I have the point 2, 4, and I reflect over that particular line, I'm going to count diagonally across the squares instead of just counting across this way or that way. So one diagonal takes me to the line. So to reflect over, I go 1 more. There's my new ordered pair. This one happens to be 4, 2. So my rule for the equation of a line reflecting over it is yx. So what happened is the x and the y, they just swap places. Okay? Then we have the next equation of a line, which is y equals -x. So this one Very similar to that one, except for the fact that there's a negative in front of the x. So likewise, nothing was added, right? So I can put plus what? 0. And again, that's still my point, so it doesn't change. And then my slope, what number goes here? 1 again, but this time my slope is not 1, but -1. I still need to make that a fraction so I can do my rise over run. So my fraction is going to be that very -1 again over 1. So this changes my rise and run direction because instead of rising 1, I have to now fall 1, and then I'm still going right 1. Okay, so from that very center point, I'm going down 1, right 1, down 1, right 1, down 1, right 1, until I've made that line. Okay, so now let's say I want to reflect that same point, but over this line, y equals -x. This one was y equals x. And notice that that line, y equals -x, is actually perpendicular to the original. So if I want to count the diagonals from this point to the line, I'm going this way. 1, 2, 3. So go on the other side, 3. 1, 2, 3. There's my new point. I've actually jumped from quadrant 1 to quadrant 4. So that is definitely going to change my signs. And it also happens to change the order of the numbers. Because this is now -4, -2, where it was 2, 4. So the rule for y equals -x reflection is -y, -x. All right, so I only really spent more time on this because I wanted to kind of review the whole graphing of an equation of a line, because you will likely have to do that at some point. All right, the last one, the origin reflection. The origin reflection is unique. First of all, it has 2 unique properties. The first thing The first unique property is that the origin reflection is a combination of the 2 first basic reflections. So if you were to combine x-axis reflection with y-axis reflection, that would give you a reflection over the origin. Okay, so that means take a point. So I'm going to use kind of an obvious point. So I'm going to start here. This is going to be my point C. And I'm going to reflect it over the x-axis first and then the y-axis, and wherever the final result is where the image will be. So if I reflect over the x first, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 would put me here, but then I have to reflect over the y now. So 9, 9 again, here I am. This is my final image, C prime. That's an origin reflection. So over the x and then the y. But I also could have done it in the other order and still ended up in the same spot. I could have went over the y first and then over the x, and I still would have landed right there. So that's the first unique thing about origin reflection. That's actually what it is. The second thing is that it has a twin. There's another rule in another type of transformation that will give you the same exact result, putting you from here to here. The rule is -x, -y. Does anyone have any idea what the other transformation might be that can put you from here to here? -y, Not exactly. There's a whole nother transformation. Not a reflection, not a translation, like a whole different transformation. No idea? That's okay. It's been a really long time since we did Unit 2. The other thing that will get you from here to here is a 180-degree rotation. So why is it important to know that an origin reflection and a 180-degree rotation are equal? So glad you asked. Sometimes they like to ask questions on the test, the EOC or the unit test, where it says, how can this figure map to this figure, select all that apply. Well, if you can identify that that mapping happened through an origin reflection, which I would have reflected it here first, and then reflected here, that's an origin reflection, it maps, so I would select origin reflection, but that means it's also going to be a 180-degree rotation. So anytime one of those is your answer, the other one has to be also if they're both options. So it's important to know that the origin reflection and the 180 rotation are identical. They will both give you the same results, and they literally both have the same rule. Any questions? Okay, so I'm gonna move a little faster through this now. Like I said, I just really wanted to go over the equation of aligned because I'm sure it's been a while since you've done that as well. We're gonna move on to rotations. Rotations are when a figure turns around a given point without changing size or shape. So if the size and the shape was not changed, that means it has rigid motion, which means it's also congruent. Good. So there's 4 rules. Oh, I missed something. Hold on a second. Look at the rules for all the reflections. Notice how they're only X's and Y's. That's it, X's and Y's. Sometimes they're switched, sometimes they're negative, sometimes they're not. Yes. Yes. So just keep that in mind. All of these rules look very similar. This is the one that's very different so far. And now we're going to talk about these rules, and they're going to look very similar to the reflection rules. So a 90-degree rotation is negative y, x. So that means the x and y switch places, and that new y has to become the opposite. The rule for the 180-degree rotation, what is that one? Remember, it's twin? Huh? Negative x, negative y. Remember, it's the twin to the origin reflection. And then the 270 rotation is positive y, negative x. So they swap places, but now the x is the opposite. And then the last one, 360. A 360 rotation is always going to put your image right back where it started, point by point. We'll end up exactly where it started. Okay? So anytime you see a 360-degree rotation, it always goes exactly back to where it started. So it maps onto itself. It's right back where the original location was. Okay, so that covers all of the rigid motion transformations. Now we have the dilation. The dilation is the one transformation that could produce a similar figure to the original by multiplying the x and y value or a side length by a scale factor. The scale factor is some number. They like to use the letter K to represent this number. Okay? So the letter K is just representing a number that hasn't been given to us yet. So depending on what K is, will determine if our figure is going to get bigger or smaller. So if K happens to be greater than 1, or the opposite of that number, so a number greater than 1, 3, negative 2, I know negative 2 is not greater than 1, but the opposite of 2 is negative 2. Any number that is actually larger than 1 will give you a larger figure, okay? Any number between 0 and 1, so greater than 0 but less than 1, this will give you a smaller figure. So what type of numbers are we talking about here? 1/2, 2/3, 0.25, 0.7, something like that. These numbers and their opposites will give you a smaller figure. In the unique situation where the value of K is equal to 1, that will give you an equal figure, the same exact points, or congruent figure. Okay, we're not really going to see that. That wasn't brought up really in Unit 2. That's more for Unit 4. But when you get these EOC questions, it's not going to be like, oh, question 1 is from Unit 2, question 3 is from Unit 7. They're not going to tell you that. They're all mixed up, and you have to figure it out. So I thought it was important to include that. So because of the fact that K could equal 1, dilations typically do not have rigid motion unless that value of K is 1, and then it would. You're not going to see that today. We're not going to have any scale factors of 1 in any of our examples today. This rule is actually very unique compared to all the other rules. The rule for a dilation, and it's really important to be able to identify a rule for a dilation, is the only rule that includes this specific operation. So we take whatever the scale factor is k, and we actually multiply it times the x times the y. This is the only rule that has you multiplying a number times the x times the y. So if you were asked to identify a dilation, what operation would you be looking for? Addition, subtraction, multiplication, or division? Multiplication, okay? Because that's the only one that occurs here in dilations. Any questions so far? Because now we're going to move into our examples. Okay, so example 1, this might look familiar because I'm pretty sure you had a warm-up similar to this sometime in the last couple weeks. We have line segment ST with coordinates S and T. Line segment ST is translated to create line segment ST prime. Prime, the apostrophe means prime. One apostrophe, one transformation happened. Okay? Then the line segment ST prime has coordinates S prime and T prime. Which rule describes the translation? So you want to ask yourself, what operation, addition, subtraction, multiplication, or division, will take me from point S to point S prime and also point T to T prime? Now, if you recognize that a translation only includes addition or subtraction, that limits what you have to figure out. But if you didn't remember that, it's not a big deal. Okay? So I'm choosing to focus on point S and point S prime. So the question is, how can I get my X value from -4 to +3? Maybe you don't know exactly what you have to do to get there, but can you at least tell me if you have to add or subtract? You have to add because the number went from negative to positive, so it got bigger, right? So even if you didn't know what number you had to add to it, because I know negatives sometimes are difficult to work with, there's two answer choices that say X minus something instead of X plus something. So we can already eliminate those wrong answers. Which ones are they? A and D, because those both say that the X value decreased by a number, but we clearly know it got bigger, right? Even if we didn't know what number it got bigger by. What about the Y value from 5 to 1? It got smaller, which means you had to. So which of the two remaining choices show the subtraction? So you've already picked your answer and you didn't even have to do any of the math. You just use logic, okay? So even if you struggle with sometimes the negative numbers, and I know some people do, I know grown-ups who still struggle with negative numbers, it happens, you can use your own logic to kind of come up with the right answer and eliminate wrong answers. So what actually happened from -4 to +3 is you added 7, and from 5 to 1 you subtracted 4. These two numbers make up the exact rule for the translation. Okay, I don't even know why I picked this up. Any questions on number 1? Okay. Question number 2 is kind of more of a following directions type of question. Did you read the question? Do you understand what they're asking you? And did you do that? Okay. Really no math involved here. There's no actual adding, subtracting, multiplying, or dividing. None of that is actually occurring here. So this question says translation A, maths, xy to x plus r, y plus s. R and s are literally just numbers. We just don't know what they are yet. Okay, we're not going to know for this problem. Then we have translation B, which maps xy to x minus a, y plus b. Again, a and b are just numbers we don't know. Then here's where the directions come in that you have to pay attention to. Translate point using translation B, then translation A, and write a rule for the final image of the point. So a rule is, what did you add, what did you subtract, in what order? So first of all, pay attention to the order of the transformation. Second, determine which one has to be done first. Which translation am I starting with, A or B? B. How do you know it's B first? It does say translation B.
It says point using and then using
And then using A. So that's your following directions. Do you know almost every other class has said translation A first? And you know why? Probably because logically the alphabet A comes before B. So our brain likes to go in that order. Okay? So we are starting with translation B. We're trying to write a rule. What is happening to the X and Y? Well, if we follow translation B first, what's happening to the X? A is being subtracted. So what do we write? Plus A. What is happening to the Y value in translation B? B is being added. So you write that. Now that we've completed translation B, we can go to translation A. What is translation A asking us to do to the X value? Add S, R. And then to the Y value, add the S. Okay? That's the answer. That's it. It's literally a following directions. Did you read the question, understand what they were asking, and provide it? That's it. You could have gotten this wrong if you accidentally put plus R and then minus A. Well, then you did A before B. So just following directions. Read your questions. Make sure you understand what they're asking. There's no numbers for any of those values, so there's no way to actually simplify that any further. That's it. That's done. Questions? Question 3. This is why I've been saying pay attention to what the rules look like, because this question is going to be beneficial to know and have an idea of what these rules typically look like. So the question is, which of the following transformations will produce a congruent figure? Select all that apply. Congruent figures have what? What's that phrase I keep using? If they're congruent, if they're the same size and shape, they have rigid motion. So we're looking for figures that have rigid motion. So there was 4 different types of transformations we talked about. Which ones have rigid motion? Translation, reflection, rotation. There's one left that didn't have rigid motion. Which one is that? Dilation. So that means we want congruent figures. We want the rigid motion, so we don't want dilations, right? So looking at these 6 options, can you identify the ones that are dilations so we can eliminate those as answer choices? What was unique to the dilation rule? Huh? Look at your dilation rule. What is different about that rule? What operation did that rule have that the others didn't? Multiplication. There we go, multiplication. Can you figure out any of these that include multiplication? So let's look at the first one. Does this one show multiplication? Nope. What about this one? 3x, 3y. That's multiplication. That means 3 times x, 3 times y. We don't want that one. There's 2 more that have multiplication.
Right.
Top right? That is multiplication and addition and subtraction. So this one is actually a combination of a dilation and a translation. Huh?
How do you know that?
Because 2x means 2 times x, right?
Oh, okay.
That means it's a dilation. Plus 4 means it's also a translation. So, but because it has the multiplication, it's still eliminated. Even though a translation would give you rigid motion, that dilation ruins it. It makes it non-existent anymore. So that one's out, and there's one more. No.
The last one, the half with the half.
The one with the half. Because negative 1/2 x is still multiplication. It's negative 1/2 times x. So that one would also be eliminated. All 3 of those for sure are dilations. Now, of course, none of us are going to be there to say there's 3 dilations. So you have to kind of look yourself and be able to do that.
so any number that has like an X behind it, that means
Yes, if there's a number in front of the X or Y with no symbol between it, that means it's multiplication. Okay? That's what you want to look for dilations. Look for that multiplication. Okay, so we eliminated all the dilation ones. There's 3 left. I, again, will not be there when you're taking your test, but you have to now pay attention to the 3 remaining, and one of those is not correct either because it doesn't look like any other rule. Which one of those 3 remaining options looks very different than the other rules we talked about?
12 minus 12.
The 12 minus x comma y. Now, what's wrong with that? A lot of people have been saying because something's happening to x but not to y. That's not the problem. The problem is that it's 12 minus x. It should be x minus 12. That would have been okay. That's just a shift 12 units to the left. But because it's 12 minus x, that does not look right. That doesn't look like any of the other rules. So that one is not going to be selected, and then the only other 2 would be. Any questions about that one? All right, the next one takes a little bit of time to get over or get through, so bear with me. Question 4. Again, select all type of question. We have vertices of a square. Remember, vertices are just the 4 corners of the square. Okay. HIJK. Which statements are true of the image HIJK after a given composition of transformations? That just means more than one transformation happened. Select all that apply. So we have step 1, step 2. These are the 2 rules that we're going to be using. Okay. So our first option that we're determining if this is true or not is H double prime is -2, 0. Well, we can actually look at point H and we can perform those operations of the rule. Okay, so if I was to just do the first rule, -yx, my original point is 0, 2. 0, 2. -yx means they swap places, so now my 2 is here, and it has to become the opposite. So what is it now? -2. So my ordered pair after only the first transformation is -yx. Oh, I forgot to ask you guys. This has 2 apostrophes. What does that mean?
That you're doing 2 transformations.
That you're doing 2 transformations. So I call that double prime, but the number of apostrophes you see, that's how many transformations happen. We already got the answer, but only with 1 apostrophe. We only performed 1. So if we perform the second one, which is 3x, 3y, what am I doing to that point now? What do I do to this point if I'm doing 3x, 3y? What operation? So I'm going to do -2 times 3 and 0 times 3. What is that going to give me? And 0. Now this is what I get for the double primed of H. So would I select that first option? No, because this says double prime H is -2, 0, but it's not. 1 primed H, 1 transformation gave me that, not both. So that one's eliminated. The next one, these next 2 are a little weird. HIJK, and what does this symbol mean? Congruent. HIJK is congruent to HIJK prime. How many transformations happened?
1.
So that says after the first transformation, which is using this rule, the 2 figures are congruent. Would they be? Congruent means they have rigid motion. Would this rule give me a rigid motion? The first one? Yes. Why?
It doesn't multiply.
Because it doesn't multiply. Okay? So this would give me a congruent figure, and that would be selected. The second one says, now we're taking the prime, so the new one after this rule, and we're saying it's, what does this symbol mean? The equal sign was removed. It's different than congruent. And I've actually used the word that this means. starts with an S, similar. So it's saying that this one is similar to the double prime. So now we're saying after I do this one, the final result is similar to the first prime. Would that be true? After a dilation? How did we define a dilation? Like in our paper, what did we write as dilation? When a figure similar to the original. So a dilation will give you a similar figure if both x and y are being multiplied by the same number. Okay, so yes, that would be true. The next one is point J double prime. So now we're doing the same thing we did for H, but for point J. So looking at point J, if I do both of those operations, those transformation rules, what will I get? Well, let's do the first one, negative x, y. So we have 0, negative 2. They swap places. The negative 2 has to become the opposite. What is it now? Positive 2. So now we're at positive 2, 0. But it's double prime J, so I have to do both. So what do I do now? Multiply times 3. And what am I going to get as a final result? Positive 6 and 0. Is that what the answer choice is saying? So what I selected? Yes. The last one. This one's fun. Kind of have to graph it, at least for this one. So this one says the line y equals x. Remember, we talked about this line earlier. It looks like this. Goes right through the center, up one, right one, up one, right one. Is a line of symmetry for HIJK and HIJK double prime. So the original and the final image. So here's the original, here's our line. Would you say it's a line of symmetry? That means it divides it exactly in half. If you folded the figure on that line, it would match on both sides. Yes, well, here's the double prime. Would you also say it's a line of symmetry for that figure? Yes. So then we would select this one. Okay. Any questions? Yes. Yes. All right. So we only have like 1 more minute. So I'm going to go through and just give you the rest of the answers, and then you can ask questions of your teacher. So, and this PowerPoint we should have uploaded as well. So number 5 is all of them except for the rotation of 90 degrees. And this is just an acronym that I use to help remember if a line is going to be horizontal or vertical. Number 6 is y equals -1, x equals +1, and the word perpendicular. I do want you to pay attention to something because it is not a coincidence. Look at the ordered pair that the reflection or the rotation is happening around. The x value is 1, and look at the equation. X equals 1. The y value is -1, and look at the equation for the line y. Y equals -1. And then those two lines, when they intersect, are perpendicular. So that's why that would be perpendicular. This is a rotation of 180 degrees, and it's saying a reflection across one line and then the other. Remember the twins? The rotation 180 and the reflection across the origin? It's just that the line x equals 1 and y equals -1 are basically shifting that origin. Okay. And then number 7 is just the last two, and I know that's kind of weird because there's only 4 options, but both of the last 2 statements are true. Water, there's somebody on right now. All right, so that's it for me. I'm going to wrap up here, and then Ms. O'Connor is going to come in and finish with unit 4.
Thank you, Ms. Nichols.